Monday, today, we're going to be doing a lab on chemical reactions. Wanted you to be able to see this without trying to come up with some pen and paper alternative. So this is going to be my attempt at trying to video it. So you're my guinea pig. If this works out, then this is probably something I'll continue to do. Because this is a test, I'm not going to spend a whole lot of time editing it. So what you're going to get is a pretty raw video. So your feedback is definitely very much appreciated. So let's go ahead and get started. So before students start the lab, here is going to be the handout. And we're in class. We're just going to kind of review elements versus compounds. I can attach the PowerPoint slide. I'm going to have a couple of elements. We're going to talk about why those are elements and then include the chemical symbol. And then I'm actually going to ask the class for some compound chemical formula examples. So if you're having difficulty filling this out, let's get together when you return. We're also going to notice that some of my elements occur, they don't like to be by themselves. They like to have another atom of the same element bonded to it. So we're going to go over that. This is what this image represents. So the elements that occur two atoms together, we still call them elements, but they just have two atoms covalently bonded together, are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So what I'm going to have is students take a highlighter, highlight this little box, elements that exist as diatomic molecules, and they're going to highlight hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, which means that those are always going to occur. So for example, we start out, our first element we started off in the PowerPoint is carbon. And we write carbon's chemical symbol from the periodic table as just C. However, for nitrogen being one of those diatomic molecules, meaning elemental nitrogen doesn't like to be alone. It's always going to have another nitrogen bonded to it. It's going to look like this, which means I have one carbon here in elemental carbon. However, here I have two nitrogens. So, need more clarification? Let's get together and talk about this. The next step before I start everyone off on the lab experiment is we're going to talk about some possible observations that may indicate a chemical change. So I want you to kind of brainstorm and come up with some possible observations and write them down. All right, so let's get started on the lab. So for chemical reactions, well, what happens to paper when it burns? Where does the light come from in a glow stick? Well, in this lab, we're going to find out what happens when sodium bicarbonate and calcium chloride mix. And then you're going to end up, throughout this lab, draw a model to explain your observations. So this is a reaction between sodium bicarbonate and calcium chloride. Here are my materials, and I have them all together. So the first thing that we're going to do is we're going to take the temperature of the room using this thermometer. So I'm going to record the temperature, and to me it looks like it is, so if I do it in Celsius, each of these little tick marks, this being 20, this being 25, is in the ones place. So that looks like at about 23 degrees Celsius. So I'm going to record, and you're going to have this, so on yours, go ahead and record 23 degrees Celsius. Then next, we're going to be reacting calcium chloride, and so we're just going to take a look at it. What does it look like before we do anything? It's a white solid, it's kind of granular, so you would write that right here. Appearance of unreacted calcium chloride. White granular solid. So back to the instructions. You know what, for ease, I'm going to go ahead and pull that off. Okay. So we record the appearance of the calcium chloride, and then we're going to go ahead and measure half a teaspoon, and we're going to place it in this sandwich bag. And I think okay, and then we're also, skipped a step after recording the temperature, we're also going to put this thermometer that we took the temperature in, we're going to put that in the sandwich bag, and we're going to get the mass of this. So the mass of the calcium chloride, the thermometer, and the baggie come to, right here is where I put my masses. So I'm going to go ahead and round just to the tenths place. So I'm going to make it easier, and I'm just going to put 4.0 grams. Okay. So my next step is I'm going to use a graduated cylinder, and it doesn't necessarily need to be on the scale, but I just limited in space, so I'm going to set it there. And I'm going to measure out 20 milliliters. And it just says approximately, so I'm not too worried about am I exactly there at 20 milliliters. And I'm going to transfer it to this beaker. I'm going to note the color of this is red cabbage juice, even though it looks purple. So I'm going to note the appearance of the red cabbage juice. I'm going to say that it's a purple liquid, and I'm going to put that here. Okay. So then what I'm going to do next is I'm going to take a look. This is my sodium bicarbonate. We also refer to this as more commonly as baking soda. I'm going to look at the appearance of the baking soda before the reaction. So again, it's a white solid. This is much more fine. It's not really granular, so kind of a white solid powder. And I put my observations right there. So then what I'm going to do is I'm going to take a 1/4 teaspoon, and I'm going to drop it into here, and I'm going to swirl to dissolve, and I'm going to use this glass stirring rod to make sure that I get all of the sodium bicarbonate dissolved in here. I'm going to check the bottom. I still have a little bit on the bottom, so I'm going to continue stirring. I want all of this to dissolve. All right, when I look at the bottom, it's almost all there. Okay, it looks like it's all dissolved, so I'm going to try and flip this so that you can kind of see the bottom of it. Do you see any particles? No, kind of a little bit. Just to say, now that I look at it again, we'll continue swirling. Almost all there. All right, there you go. If you look at the bottom, yep, it's all dissolved. Okay. Note the color change. It went from purple to kind of a green-blue or a teal. So I'm going to indicate appearance of red cabbage juice with the sodium bicarbonate right here. And I'm going to note the difference in the color. Okay. So now what I want is I want the mass of this beaker with the sodium bicarbonate. So my balance is zeroed, and I go ahead and I put it on there. And again, for ease, I'm just going to go ahead and round up. So I'm going to record 95.6 grams right here. Okay. So as I'm moving through here, this total mass before reaction, I'm just going to add these two together to get the mass of everything that was involved in the reaction before I actually put the two things together. I'm going to go ahead and get the calcium chloride to one side of the baggie, and I'm going to pour the cabbage juice in the other. Nope, not. And I'm going to go ahead and mix. I'm recording this for a student who's not going to be here. And I'm just mixing by kneading. That's all right. I already told her I was going to give her the raw footage if this works. So I've mixed the two together, and I'm going to let this sit for about 3 minutes. So if you can't tell in the footage, it's got a foamy texture. It's obviously turned lavender. The bag is poofing out a little bit. So before I mixed, I tried to push out as much air out of the bag as possible. So the bag was pretty thin. And so the bag's poofed up a little bit. I've definitely gotten the thermometer, the mixture on the thermometer, because I'm going to want to take the temperature when I'm all done. So I'm going to let it react for about 3 minutes. So while I'm letting that react, I can start adding observations during the reaction. So things about how it turned lavender, it's foamy, the bag expanded, you know, it's foamy, but there's some liquid. Okay. So what I want to do now is I want to get the mass of everything after the reaction. So I'm going to make sure my balance is zeroed. I'm going to put the beaker on here. And then just for ease, I'm actually just going to put this whole thing in the beaker. And that comes out to a mass, again, I'm just going to round to the tenths place, of 110 grams. Okay, so when I add everything together, I should get, so this is actually a 0.6 gram, nine. So before the reaction, my mass was 109.6 grams. After the reaction, it was 110 grams. That's pretty close. Okay, I lost 0.4 of a gram. Really what this is demonstrating is that I didn't have a loss in mass. Okay, because I was rounding, this is pretty negligible, that 0.4 of a gram. So my mass was pretty much the same before as it was after. So there's going to be some questions to ask about that. Okay, so my next thing is I'm going to take a coffee filter. This asks you in the instructions to write your name on it. That's really only because we're going to have our precipitate dry, the solid. We're actually going to form a solid. We're separating our solid out of this liquid, and we're going to test the solid tomorrow. We're going to test the solid tomorrow. So writing your name on it is really just so that you can find the stuff. You can get your stuff tomorrow. So pretend my name was written on there. We are going to open this up. I am going to read, before I filter, I'm going to read the temperature on the thermometer. So I'm going to carefully take the thermometer out. I'm going to wipe some stuff off. And I'm going to notice here that my thermometer is actually below, still in the 20 mark. It's right here. That actually looks like it's reading maybe 21 degrees Celsius. So 20, 21 degrees Celsius. Okay. So I'm going to write that as temperature after the reaction. So we're going to notice that the temperature went down. What's the final appearance of my reaction? It's kind of lavender. There's kind of a liquid. We're going to put the filter paper in there, and this is where it's handy to have two people. And I'm just going to pour that in there. Okay, so this is going to end up filtering. So we're going to go ahead and let it filter. And I'm going to go ahead and pause while I go ahead and get things cleaned up, because this is going to take a few minutes. Okay. I went ahead and filtered it. I forgot to show you how I took it out. I went ahead and filtered it. I took my filter funnel out. I opened it up. And we're going to let this dry overnight. So my questions are, what's the appearance of my solid? We're going to call this solid a precipitate. So something about, it kind of looks chalky, milky, lavender color. And then also, what's the color of my filtrate, or the liquid? And that's what's in here. So again, it's kind of that purple color. It's a little bit milky because I still actually have some of the particle, the solid got through the filter paper. If I let this set through tomorrow, it would actually be a little bit clear, and I'd have some solid on the bottom. But note the color of it. So that ends this part of the experiment. So with this part of the experiment, there's some questions. Did the temperature increase or change? If so, did it increase or decrease? It talks about why we use the cabbage juice, so go ahead and read that. What happened to the particles in the sodium bicarbonate and when the calcium chloride mixed. This is where you would draw your model to your understanding right now of what happened. This will more than likely be modified as we continue through this unit. Here's a question on bakers use sodium bicarbonate, which we also refer to as baking soda, to make cakes and other baked goods rise and become nice and cakey. So based on this model here, why do you think sodium or baking soda causes a cake to rise? So again, noting that you weren't here to feel it, but my baggie got kind of nice and foamy and soft and light. So that might have something to do with the chemical reaction involving sodium bicarbonate or baking soda, and why a baker would use that product. On the back side, so based on your observations, list 3 signs that you believe a chemical reaction occurred. Here's where you're going to input your data about your mass, your before and after, and then think about what law might explain any differences or similarities in the before and after mass. And then here's kind of a wrap-up question. Using question 6, in a chemical reaction, the starting materials are called the reactants, and the substances created as a result of the reaction are called the products. So 3 wooden logs with a total mass of 15 kilograms are burned in a fireplace. After burning for an hour, they are left to cool and then reweighed. The total mass of the logs after burning is 8 kilograms. So what do you think happened to the rest of the logs? Explain your answer using what you've learned from this lab, and then don't forget to use the terms reactant and product in your explanation. So that wraps up today. What we're going to do for tomorrow is, again, this is going to go ahead and cool overnight, and it ends up looking something like this. So tomorrow what we're going to do is we're going to confirm that a chemical reaction actually happened by placing each of my reactant in a beaker. And I need to Let's see if this works. Plus what I've created. So I'm just going to flake it off of here. And you want actually a 1/4 teaspoon, but I'm just going to go ahead and dump the whole thing because that's kind of close to a 1/4 teaspoon. I'm going to put it all in there. So if I made a chemical reaction, my product should have different properties than my reactants. And let me get some water. So we're going to test for solubility. So the solubility of my sodium bicarbonate. I'm going to put about the same, so that's about 10 milliliters. I'm going to swirl. I've almost got all of it to dissolve. I'm going to let that sit, and I'll come back and continue swirling. I'm going to have this go a little faster. Okay, here's my calcium chloride, my other reactant. This has got a little chunk in it. Oh, does it? There's that. Okay, no, it's gone. Okay. So I'm going to swirl that. So that looks nice and dissolved. Okay. Still got a little bit in here. Touch more water. Okay, that looks nice and dissolved. They're both nice and clear. Okay, now I'm going to add my calcium chloride. And first off, what I notice, so the color is from the red cabbage juice, so we're going to not worry about the color difference. But we're going to notice I don't have a nice clear solution. And I'm not able to dissolve my product. If I filtered it out, I'd end up with the same thing in the filter paper and water on the other side. So, reactants are soluble. Product, which is something totally, completely different, is going to have different properties. So, soluble, insoluble. Not soluble, does not dissolve in water. Dissolves in water, does not dissolve in water. So that's kind of one way I can prove that a chemical reaction actually happened. So we would pick up on this tomorrow, do this part of the experiment, and then for the rest of class, we're going to explore how to balance chemical equations. And that involves a worksheet with some Lego activities, which I will go ahead and try to send to you. You don't need to use Legos. You could use anything. If you have little toys, even little candies with each different candy representing a different atom. So go ahead and try and explore that, and then when you return to school, we'll try to get you back on the same page. So again, I would very much appreciate your feedback if this helps at all and allows you to participate in the lab experiment. So if you start noticing this, I've got my clear water, clear colorless water on top with, again, my insoluble product on the bottom of the beaker. All right, hope this helps.